Today we're going to be looking at ways to find the derivative of a composite function. And the rule that we're going to be using for this one is something called the chain rule. So let me go ahead and tell you what our chain rule is to start with. Okay, so let's say we have a function y is equal to f of u, where u is some g of x. What the chain rule tells us is if we want to find dy dx, so the derivative of y, the way that we do this is we first find the derivative of y with respect to the variable u, and then we multiply that to the derivative of u with respect to x. So basically what this is saying is we start by finding the derivative of the function on the outside, and then we multiply that by the derivative of the function on the inside. So another way of saying this would be, let me say equivalently, another way of saying this would be d dx, so the derivative with respect to x, of the composite function f of g of x is equal to f prime of g, so the derivative of the outside function, times g prime of x, so the derivative of the inside function. Okay, all right, so this is our chain rule. Now, of course, all of these rules make a lot more sense when you see them applied to an example. Well, let's look at some examples. And we're going to find the derivative of each function. Okay, let's start with y is equal to the square root of the quantity x squared plus 1. Okay, so in this case, the square root is the outside function, and then x squared plus 1 is the inside function. All right, now just like we've done in the past when we want to take the derivative of any kind of radical, I'm going to go ahead and just rewrite that square root as a 1/2 exponent first. All right, before we even take a derivative, we just need to rewrite it. All right, so now using our chain rule, let's find the derivative of y. Okay, so what our chain rule up here says is we're going to start by taking the derivative of the function on the outside. So in this case, that means taking the derivative of the square root. So with that, we're just going to use the power rule. So pull the 1/2 out front. We'll still have the x squared plus 1 on the inside. That doesn't change. And then subtract 1 from our exponent. Okay, so that's the derivative of the outside function. Now we multiply that by the derivative of the inside function. So the derivative of x squared plus 1 would be 2x. Okay, so that's our derivative. Now we just need to do some algebra to simplify this down a little bit. So remember what we talked about in previous videos. Typically, we want to rewrite our equations with positive exponents instead of negatives. And if the original equation started with a radical, you typically want your final equation to end with a radical as well. So I'm going to go ahead and rewrite this. So my 2x is going to be in the numerator. The 1/2 here is going to put a 2 on the bottom. And then since we have the negative 1/2 exponent, that's going to go on the bottom as well. So x squared plus 1 to the 1/2. All right, and then we can just simplify this a little bit. So we can cancel our 2's out and then just rewrite that 1/2 exponent as a square root. So we would have x divided by the square root of the quantity x squared plus 1. And that is our derivative. Okay, so this is the chain rule. So take the derivative of the outside function and then multiply it to the derivative of the inside function. All right, let's look at some more examples. Let's try y is equal to 1 over the quantity x plus 1. All right, now one way that we could do this function, take the derivative of this function, would be to use the quotient rule that we looked at in the previous video. Instead of using the quotient rule on this one though, I'm going to go ahead, since it's only a constant in the numerator and we don't have a variable in the numerator, what we can do is we can just bring the denominator up as a negative exponent. So I'm going to go ahead and rewrite this as x plus 1 to the power of negative 1. Okay, by doing that, it makes it a chain rule problem instead of a quotient rule problem. Now, either way, you would get the same answer. It's just kind of personal preference on which route you would like to go. All right, so now let's take our derivative. All right, so just like the last one, we're going to start with the outside function, which in this case is our whole thing raised to the power of negative 1. So we'll just start with our power rule. So pull that negative 1 out front. We still have the same x plus 1 inside our parentheses, and then subtract 1 from the exponent. Okay, and then the chain rule says we'll now multiply by the derivative of the inside function. So the derivative of x plus 1 would just be 1. And then just simplify this a bit. So I don't like that negative exponent there, so I'm going to put that in the denominator. So we would have negative 1 divided by x plus 1 quantity squared. And that's our answer. All right, let's do one with a trig function. Let's try y. Y is equal to, let's do tangent squared of x. Okay, so to think of this as a composite function, just recognize that we're saying we have the whole tangent function quantity squared. So the square is our function on the outside, and the tangent is our function on the inside. All right, so let's go ahead and take our derivative. All right, so starting with the outside function, which is again the square, we'll just use the power rule. So that'll give us 2 times tangent of x raised to the power of 1 if we subtract. And then multiply by the derivative of the inside function. And hopefully you remember from the previous video that the derivative of tangent is secant squared. All right, and then I can just clean this up a little bit, just losing some of the parentheses here. So we would have 2 times the tangent of x times secant squared of x. And that's our derivative. All right. Let's look at one that's a little bit more complicated. Let's try f of x is equal to x squared times the square root of 1 minus x squared. So in this case, we're going to have to use both our product rule, because we have these two functions that are being multiplied together, as well as the chain rule, because this piece right here is a composite function. This one's going to be a little tricky. So I'm going to start like normal just by rewriting my square root as a 1/2 exponent. We'll have x squared times 1 minus x squared, all raised to the power of 1/2. Okay, so like I said, there's going to be a lot going on in this one because we have both a product as well as a composite function, but we'll just work through it step by step. Okay, So remember our product rule says we start by taking the first function, so x squared, times the derivative of the second function. All right, so when we're taking the derivative of this piece, we're going to have to use our chain rule. So start with the outside. So we'd have the 1/2 out front, and then subtract 1 from our exponent. And then still using our chain rule, multiply by the derivative of the inside, which would be a negative 2x. Okay, now just back to our product rule. So we had the first function times the derivative of the second. Now plus the second function times the derivative of the first function. So the derivative of x squared would simply be 2x. All right, so that's our derivative. Now for all of our cleaning up with our algebra. So lots of simplifying to do here. All right, so first of all, I noticed that we have a 1/2, and that's being multiplied by a 2 in here. So I'm just going to go ahead and cancel those just to simplify a little bit. Also, we have an x squared times an x, so that's going to give us an x cubed. Right, and it was a negative right there, so a negative x cubed. And then with my negative exponent, I'm going to put that in the denominator. So that'll be a 1 minus x squared to the positive 1/2. Okay, and then for the second piece, there's not really too much we can do with that just yet, so I'm just going to leave it alone for a second as the 2x times 1 minus x squared to the power of 1/2. Okay, now I'm going to rewrite both of these 1/2 exponents as square roots. So negative x cubed divided by the square root of 1 minus x squared, and plus my 2x times the square root of 1 minus x squared. All right, now to keep simplifying this a little bit, because we have this fraction that's being added to this other term, I want to go ahead and put all of this over a common denominator. So I'm going to think of this guy as being over 1. So our common denominator would just be this radical. So I'm going to multiply this second term by the square root of 1 minus x squared over the square root of 1 minus x squared to get that common denominator. All right, so then we would have negative x cubed plus 2x, and of course, square root times itself is just going to give you the radicand, so that would just give us the 1 minus x squared, and that's all over that common denominator, square root of 1 minus x squared. All right, a little bit more simplifying to do here. So now just in our numerator, we can distribute that 2x in. We have negative x cubed plus 2x minus 2x cubed, still all over square root of 1 minus x squared. And then lastly, just combining like terms. So negative 3x cubed plus 2x divided by the square root of 1 minus x squared. And that is our final answer. All right, let's take a look at another tricky one. Let's do one that's a chain rule and a quotient rule. Let's try on this one. F of x is equal to x divided by the cube root of the quantity x squared plus 4. All right, so this time we have a quotient, the x divided by that cube root, but we also have a composite function on the denominator, so we'll have our chain rule for the derivative of the denominator. All right, so as usual, I'm just going to rewrite my radical as a 1/3 exponent. All right, now we can take our derivative. Okay, so starting off, to take the derivative of this, we'll need to use our quotient rule. So remember, we start with the function in the denominator times the derivative of the numerator minus the numerator, and then multiply that by the derivative of the denominator. Okay, so here's where our chain rule comes in. So start with the derivative of the outside function. That's just going to be using our power rule. So bring the 1/2 out front, and then subtract 1 from your exponent. Will give us a -2/3. Right, then times the derivative of the inside function, which would give us a 2x. And then all of that over the whole denominator squared. Okay, so that's our derivative. Now for all of our algebra to simplify this down. Okay, so I'm just going to clean this up a little bit. So we have our x squared plus 4 to the 1/3 here. And then for the second piece, we have an x times a 2x. So that's going to give us a 2x squared. The 1/3 means our 3 is going to go in the denominator. And then with a -2/3 exponent, that's going to go in the denominator as well. Okay. And then that is still all over x squared plus 4 all raised to the 1/3 squared. Okay, I'm actually going to go ahead and rewrite that denominator. I'm going to simplify that in this step as well. So an exponent raised to an exponent, you just multiply. So I'm actually going to rewrite that as an x squared plus 4 to the 2/3, just to clean it up a little bit. Okay, so just like the previous example, we need to clean this up because we have now this fraction over top of a fraction. So instead of just getting everything over a common denominator this time, I'm just going to go ahead and multiply everything through by the LCD. So our LCD in this case would be this piece right here, the 3 times x squared plus 4 all raised to the 2/3. I'm just going to multiply everything through by that. And of course we have to do it to both the top and the bottom. So multiplying everything through by that LCD. Okay. So for this first piece, we have x squared plus 4 to the power of 1/3. And if we multiply by an x squared plus 4 to the power of 2/3, we just add our exponents, but 1/3 plus 2/3 is simply 1. So this is just going to become 3 times x squared plus 4. And since it's a power of 1, we can just leave that off. All right, so then for the second term, since we multiplied by this denominator, those are just going to cancel out, and it just leaves us a -2x squared. All right, and then on the bottom here, we have an x squared plus 4 to the 2/3, and we're multiplying by another x squared plus 4 to the 2/3. So again, adding our exponents, that'll become a 4/3. So that's 3 times x squared plus 4 to the power of 4/3. All right, we're almost done. So distribute that 3 in the numerator to give us 3x squared plus 12. And so minus a 2x squared. And that's all over 3 times x squared plus 4, all raised to the 2/3. And then combine our like terms. Then we get x squared plus 12. And that's all over 3 times x squared plus 4. Oh, I'm sorry. That's a 4/3 right there. Same thing down here to the power of 4/3. Okay, now you can leave it right there if you want to, or you can rewrite that denominator as a radical. So the last thing you could do with it, if you chose to, would just be to change that to a cube root of x squared plus 4 to the power of 4. So either one of these two would be an acceptable final answer. Okay. All right, guys, I'm going to leave our video right there for today so as not to make it too long. There are a lot more examples in the notes that I posted, so definitely take a look through those, but we'll leave the video there.